So the next and the last talk before the lunch break is Mattis Haase. He's talking about checks. They don't suck. So let's see how that will work out. Thanks for coming over, and it's your stage.
Yeah, thanks. My name is Mattis Haase. I work for a German MSP in Göttingen called C-Store. I'm here to tell you how to write checks that I think don't suck. But in order to write monitoring plugins that don't suck, you first have to be able to write a monitoring plugin, regardless of its suckage. So I would like to know who of you already know how to write a monitoring plugin. Okay, it's about 50%. That's absolutely no problem because it's ridiculously easy. In fact, I'm going to write a completely working monitoring plugin in under 10 seconds. So right here we have a service, and this is the check plugin for that service. So I'm now going to change the status to OK, right? Done. As you will see in a second, this service will now change from unknown to OK. Why does this work? Because the state of a service is just changed. The state of a service is determined by the exit code. So if the exit code is 0, the state is OK. In fact, I can delete this line, and it will still be OK because it's Python. So it will open this file, it will execute it. The file is empty, so there are no errors. So it terminates without errors, so the exit code is 0. And it stays OK. So you already saw I use Python. You can use any programming language you want. You can use not only real programming languages like C. You can use scripting languages as well, like Bash and Python and Perl and Ruby. Everything you want, maybe even PHP if you wanted to do that for whatever reason. You can do it. COBOL might not work. I haven't tried it out. Pretty much what the language needs to be able to do is you need to be able to set an exit code, and you need to be able to write something to stand it out. So the state is determined by the exit code. 0 is OK, 1 is warning, 2 is critical, 3 is unknown. By the way, this page, which I did not save as PDF and gave you for download, will be like a one-page cheat sheet. So if you want to make a picture of this later on, it will have all the info you need to write a monitoring plugin. So we already know how to set the state. You're 1/3 there in understanding how to write a monitoring plugin. There are only 2 more things you might want to do. Number 1 is you might want to have an output. And that's really easy. You just write something to std out. So this is a check output, for example. Right, I just print this. In Bash, it would be echo. In, I don't know, PowerShell, it would be write hosts or whatever. You just send it to std out, and it will show up in the plugin output. So now we already know 2 of 3 things we need to know to write a monitoring plugin. We can set the state, and we can have check output. There's only one more thing, and that's performance data. We all love graphs. So if you want to have nice graphs, you need performance data. Also, as you might imagine, really simple. So, because performance data starts after this pipe symbol, right? So make a pipe, and then you have a space-separated list of key value pairs. So you have something like metric 1 equals, I don't know, 3.1, like this. Metric 2 equals like 5. And that will show up as performance data in your check as soon as it updates. Somewhere down here. Ooh, right? So now you already know all 3 things you need to know in order to write a check plugin. The status is just the exit code. Output is just standard out. And performance data starts after a pipe symbol. And then you have a space-separated list of key value pairs. If you want to make a photo of this slide, now is your chance. OK, photo was done. Great. All right, so now we know on like a high level, or actually on a low level, how to write a check. But how do you actually do it in reality? It's always a 4-step process. So step number 1 is you need to gather some information of stuff you want to monitor. And you should take some time on this, because you might think, like, I don't know, I want to monitor memory, and you want to write your own check for whatever reason. You might just run a command like free-m and take that data, right? But there are multiple ways in which you can gather this data. You could, for example, also look at this file. And there are always multiple ways to get data. And usually for your environment, one way will be better, and it will be easier to maintain. So don't just use the first thing that comes to mind. Think about in which ways you can gather the information. So you have your information. Now you need to parse the information. You need to take whatever is in that file, whatever that command gave you, and you need to translate it into an internal representation that your program can work with. After you did that, you can actually do the internal logic, which is what decides, is this okay? Is this warning? Is this critical? Do I do anything else? And then you only need to translate it back to human-readable language. And as it turns out, number 1 and number 3 are maybe 10 lines of code. It's not difficult to gather data. Usually, if you have something really weird that only talks via serial, and right, then it might be a little bit more complicated. But most things you want to monitor, in my experience, maybe the 10 lines of code to do that. And the internal logic is just, is this value bigger than my critical value? Then the status is critical, right? So that's not a lot of work. The work are steps 2 and 4. And in fact, step 4 is what this talk is about. How do you have an output that is not a complete mess? And I will show you a complete mess in a second, just to show you how not to do it. So who now knows how to write a monitoring plugin? AKA, did you understand what I just talked about? Okay, it looks a little bit better than before. Okay, that's good. So now we can start the actual talk. So I thought about how I can show you what I actually want to talk about, and I thought let's just do an experiment, okay? And we're going to repeat this experiment a couple times, and we're going to have nifty graphs and so on at the end. So the next slide is a real-world check output, which sucks. And I'm allowed to tell you it sucks because I was the one who wrote it many years ago. One hard drive is broken, so you will see somewhere in there will be hard drive information, okay? So here's the experiment. Really, imagine it's 3 a.m. in the morning, okay? You get this email with this check output, okay? One hard drive is broken. As soon as you figure out which drive is broken, raise your hand, and I will measure how long it takes you to figure out what's actually wrong, okay? It's really simple. Here we go. Okay? But I want to see like how long does it take on average. So we already have like 50 seconds. Okay, so let's start. Let's start this. So the fastest one was 10 seconds, which is pretty good. And then the average was like 15 seconds. So it's right here, by the way. Here. Right, obviously. Obviously. So this check, it sucks. This is a check where I would say this check sucks. And I think you all agree with me. Now, the reason is, why does it suck, though? And I would say there are multiple reasons why this particular check sucks. The number 1 reason, and the most important one, though, is that it's unreadable mass, right? It's just a big blob of text, and it's difficult for humans to parse this. A computer wouldn't care, but we are not computers. We are humans, so the check output needs to be written for a human and not a computer. It's difficult to quickly skip between values, even when you arrive at the part where you see now we have all the disk statuses, stat whatever. It's difficult to go from one to the next because they're all in one line and then there's a line break. So that's difficult. And it's easy to get lost because when you read something, your brain needs a point where it can anchor to in order to navigate through text. And if you don't have any points you can anchor to because it's just a giant blob of text, it's difficult. So that leads me to rule number 1 of making checks that don't suck. It's to make it readable. You can make it readable in multiple ways. So number 1 is formatting, okay? There's a revolutionary technique, okay? Really, revolutionary. I've never seen it used on any of the plugins, on monitoring plugins or whatever, okay? It's new line. It's actually possible with today's technology, and I thought you might not believe me, so I'm actually going to show you. Yeah, whatever. So we can actually do something like this, okay? This is a multi-line \n check output, okay? Okay. And let me zoom up here. As we'll see in a second, it will actually be a genuinely multi-line check output, as in we now actually have paragraphs in our check output that we can use to navigate, right? That's great. But there's more, okay? You can use HTML tags, not all HTML tags, but you can use some HTML tags. You can make stuff bold, italic, you can underline, you can also use break if you don't want to use new line for whatever reason. You can also use HTML tables if you want to. If you have lots of data, it makes sense to put it into a table. By the way, all I'm talking about, I only tested with Icinga Web 2. Different things work with different dashboards. With Icinga Web 2, there are things that don't work. Okay, you cannot use CSS. You cannot use emojis. I tried. And you cannot use JavaScript. Okay, JavaScript and CSS, I mean, no one wants to use CSS, and JavaScript makes sense. It must be cross-site scripting, but it's 2017, so I think we should be able to use emojis. Anyway, basically what happens is the check output is passed through a PHP module named HTML Purifier, and that strips out all stuff that could be bad, right? And actually, I think there's a bug in Ubuntu 16.04, I don't know if it's fixed yet, where if you try to have HTML in your check output, it will not work because HTML Purifier changed its location. It's fixed? OK, great. All right. So if you get that error, just update to the newest version, and it will work again. OK, so make it readable by formatting. You can use these 3 really simple things, like tables, HTML tags, and new lines. But there's a different thing when we talk about making something readable, and that's the language that we use. I remember the first time I wrote a monitoring check for a Synology NAS, and it used SNMP. I used SNMP for it, and it has system state 0 to 5. And I was just like, OK, I'm just going to dump it all into the check output, right? So I have all the information. And then you get an alert. It's like system state equals 3. And you're like, OK, what is system state 3? Now, if you have binary things like 0 and 1, then it would kind of make sense to use 0 and 1, but it's still ambiguous, right? Why don't you use one line of code to write it out? Okay, translate that 1, that 0, to write it out, because first of all, everyone who who didn't develop the plugin, aka everyone but yourself, will not know what system state 4 or whatever means in the first place, and you yourself will forget after half a year. For sure. So take like one line of code. It's one line of code to write it out. OK, great. So now we're going to implement what I just talked about and see if your response time is a little bit better. So next slide is a real-world check rate check output. One hard drive is broken. Imagine getting the following mail 3 a.m. in the morning. As soon as you figure out which drive is broken, raise your hand. Here we go. The first one? Oh, great. OK. So the first one was like 3 seconds. I think I made it a competition, so everyone is trying to be really quickly. So this still sucks. OK, it's better. Like, it's definitely better than what we had before. I also want to show you that actually now we have offline right here, right? Instead of 0. But this is a server that has 8 hard drives. OK, imagine this check output if you had a SAN with like 96 drives, Okay, every single one of these like model numbers and ports and so on, it would be repeated 96 times instead of 8. So there's redundant information in here. And I don't like redundant information. For example, the disk port thing is completely redundant because drive 0 means drive in port 0 already, right? It's already in there. Just why would I waste 8 lines of check output showing you this? It doesn't make any sense. We have multiple disks that have the same information. All the disks here are SSDs. All the disks, have the same bandwidth, and so on and so forth. And we repeat that. Again, if this was a SAN with 96 drives, that would be maybe like about 100 lines of just output for every single thing. And some info, and this is a pet peeve, because every monitoring plugin does this, and I don't understand. They have the perf data in the check output, and then again in the perf data, which I don't understand at all, because the reason we have perf data is so it's separated in the UI. So why do we, right? If you have something like check load or check mem, right? It's one line. Okay, I can then it's okay, right? But if you're checking multiple things, like in this case, for example, temperature, then it becomes lots and lots of info, and no one is actually reading perf data really in Icinga, usually, right? Most people just parse it into Prometheus or Grafana or Graphite or whatever, and have it graphed there. So don't have perf data cluttering your check output, okay? Because you don't need to have anything here, right? This can be empty. Don't feel the need to I have to write something there. You don't. If there's nothing useful to say, then it's better to not say anything. There are more reasons, though, why it still sucked. So there's redundant information, but there is also useless information. For example, and that depends on your environment. Like what information is useless and what information is useful for you depends on how you do things. You might have, for example, an inventory system, in which case, if you list the serial numbers of all the drives, you probably don't need this, right? Also, things that are working are not interesting, right? Under Unix, there is this design philosophy when you write a Unix command to treat the attention of the user as a resource and don't just waste it. So if a program runs and there's no error, it doesn't tell you that there wasn't an error, it just runs, right? If you're, let's say, I don't know, GitLab, and you run rmrf/, it won't tell you that you just deleted the production database, right? It will just work. So the same thing here. Things that are working are not interesting. If I have a check and the check is status OK, I know everything is OK. That's the definition of it being OK. I don't need to know every subsystem that is also OK, because I know that everything is OK. At the same time, if only one thing is broken, and I get this as an email or as a ticket or whatever, I only care about the broken thing. I don't care about all of the little things that are working. So this leads us to rule number 2. Show only the minimum information necessary. Okay? Avoid redundant information, like perf data, for example. And don't show information you don't need. Okay? And try and group similar things together. So if you have 28 things that are all the same thing, group them together. Okay? So let's look at how that will look. I don't even know if I have to start. So next slide is a real-world RAID check output. One hard drive is broken. Imagine getting the following mail 3 a.m. in the morning. As soon as you figure out which drive is broken, raise your hand. Okay, yeah, wait. So that's like 2 seconds and 2 seconds. So this, if you're, like after this talk, if your check output looks like this, I'm already really happy, because this is already pretty good, right? This has the same information as this. It's the same. There's the same amount of information in both of these things. By the way, yes, I know of the controller serial here, right? This might not be necessary. But we have the same information in both of these things. But think how much more readable this is. Like, for the first check, you needed 15 seconds to figure out which drive is broken, and now you're down to 2. Only by doing a couple of pretty simple things, right? All of this is programmatically not difficult to do. However, I argue that you can do it even better, okay? And this won't work for everything that you might monitor, but it will work for many things. Remember that software exists to aid man, okay? If you have a check like this, and I know I have the perf data in the check, but if you have a check like this, okay, and you actually cared about this server and about the load on this server, which is not a given, right? But if you cared about it, and you got this email, what is the first thing you do? You probably log in and you run top and figure out like what is actually using all this load. So why don't you have your check do it for you? Okay? If there's something, if you have a situation where when something is happening, you always do a specific thing, always, to get more information, why isn't your monitoring software doing it for you? Software is there to take work away from you, okay? It's nice that it tells you that something is wrong, but if you're going to need this information down here anyway, then why not aggregate this information, gather this information, and present it immediately? Because it's a difference if it's 3 a.m. in the morning again, right? And it's a difference whether you get, critical loads and then you have 5 times rsync and the backup is not running or whatever, or your MySQL crashed, right? That's a difference. In one case, you might turn over and sleep a couple more hours. In the other, probably not. So rule number 3 is let the check do work for you, okay? Spend some time and think about, okay, what is the actual use case for this monitoring plugin? If something goes wrong, what information would the employee actually need to solve this issue at hand? And then aggregate that information to the check output. Now, this could be many, many, many things, right? This could be something really simple. It can be something really complex. If we heard about monitoring fans, for example, it's a good idea to monitor fans. And you have 8 fans, right? And 1 fan breaks, then the only information you probably need is this fan is broken, and that's enough. But if you have something like this RAID check, for example, and 1 hard drive is broken, what would be the next thing you do? You probably have to replace the hard drive. What do you do? What do you need to know to replace the hard drive? At least you need the model number, you need the serial number, and so on and so forth. So think through this. What is the possible information that you could need, or that an employee could need, and then gather that information, compile it into one thing, right? This could also mean that your monitoring plugin maybe communicates with other systems. Maybe your inventory system has an API. Maybe it makes sense for your monitoring plugin to go like, oh, this hard drive is broken. Dear inventory system, what's the serial number of this hard drive? What's the warranty status, and so on and so forth? What's the phone number I need to call to get a new one? Whatever. So, all right. I implemented this. So next slide is a real-world RAID check output. 1 hard drive is broken. Okay. Imagine getting the following email 3 a.m. in the morning. As soon as you figure out which drive is broken, raise your hand. All right. Sure, yeah. So this is like the ideal state, because if you are a sysadmin, or your employees are sysadmins, and they get this email, all the information they need is in there, okay? First of all, the check output changes, okay? It's a different, if everything was okay, it would look totally different. Now that something's not okay, it presents you with additional information. For example, when I check for fans and everything is working, my check output is nothing, because it's working, it says it's okay, there's like, the perf data is in perf data, right? You don't need to know anything else. But if 1 fan is broken, the output then is fan number 5 is broken, right? All right. So in summary, before I talk about some other things that are also kind of cool, but in summary for making check outputs that don't suck, Number one, makes the output readable, right? By using formatting and specific language. Again, if like all you take away from this is that you can use newline, that would also already be great. Only show information needed and group information together when it makes sense to group it together. And also, has to check accumulate relevant information for you. Okay, so this was also 2 seconds. Apparently that's the minimum time someone needs. So let's make a nice graph, because why not? Where is it? Oh yeah, it's in the data, right? No, it's not in the data. Insert? Oh yeah, I have to click on chart. Yeah, right. That makes perfect sense. Okay. See how nice it is when like the time you need to actually see what the problem is to create this like this. So yeah, this is nice. There are some other things that I will optionally talk about when I talked way too quickly, like I did today. One of those things, okay, that also drives me mad is error handling in your monitoring plugin. Okay, your monitoring plugin will crash every now and then, and here's something it should not do: go to critical and send you like an email every hour telling you that it crashed again. That is something that shouldn't happen. There is an unknown state, and that's the use case for the unknown state. In your if you use Python, you could just use a giant try except, right, around everything. And then, if there's any error, you go to unknown state and you print the stack trace. So the stack trace is my check output. And then I can decide, do I want to notify on unknown, aka when the program crashed, or don't I want to notify on unknown? But I'm not forced into getting notifications because it's critical all the time. And you can debug it because it's in the check output. That would also be really nice. Lastly, something that I really like is I don't deploy monitoring plugins at all. All of my monitoring plugins are agentless because most of the stuff that you need, or all that I can think about, I only monitor Unix machines. So, if you have Unix machines, then out of luck, right? But if you have Unix machines, you can do everything via SSH. You don't even need to deploy your monitoring plugin on the target machine at all. In fact, I have written a couple of these that you can download if you want. If you go to our page, which is github.com/cstore, you go to Icinga 2 checks and look at the amazing amount of updates it gets. But there are a couple checks up there that are all agentless, mostly, except these, it's a local, right? But the majority of them are agentless. Some of them still suck because some of them I wrote like 2 or 3 years ago when I didn't know any better, right? But there's some good stuff in there, so you could definitely try that out. And we still have some time for questions. Yes?
When you use the formatting in the output, does that work with SMS?
Does it work with SMS?
It was just more like in my opinion, recommendation to not use HTML as a checkout because you don't know like if any systems who forward
Yes.
checkout how they handle it, like different
Yeah.
user interfaces. You might use Scrap, you use Classic interface or anything.
Mm-hmm.
They might render it differently and shows up differently. So line break, so working great
Yep.
most of the time. But yeah, if you have HTML output and then you send it to someone who doesn't know any HTML.
Yeah.
They are really screwed.
Yeah, that's a great remark. One sec. The question was, does it work via SMS? And then we had a remark by the Icinga Web 2 guy who said that if you use HTML and you forward it to a system that doesn't use HTML, then it will screw up, right? This is true. What I said here with HTML, all this stuff works with Icinga Web 2, right? It does not necessarily work with other systems as well. But that doesn't necessarily mean that it's a bad idea to use HTML, but you have to think it through, right? If anywhere down your pipeline you have something that doesn't understand HTML, then you have to think about that as well, right? Any more questions? Yes?
How would you check performance if you have like 3 broken disks, one greater and one is rebuilding on the hot spare? Will show different lines for each device? Because it was an easy example.
Yeah, right.
I'm wondering how you get these lines into when there are different things broken.
Yes. This depends on your workflow and on your environment. You need to think this case through, and you need to think, what information do I need? What's the most important information for me? And you need to figure out an output that makes sense for you. What I have here, right, is an output that makes sense for the environment that I work in, but it's not necessarily the best for you. You really need to think about, if I was an employee, right, it was 3 a.m. in the morning, and I would get an alert, what would I like the notification to be so I can do my job most effectively, right? And this will be different depending on your environment and what exactly you do, right? If you have multiple things that are broken, I would still put the broken things, personally. I wouldn't be able to put them in one line if I had 3 broken things with, one rebuilding and so on and so forth. But I would have a line for everything that is out of OK status, right? Showing all the information I need to do this specific thing, to solve this particular issue. Does that make sense?
Makes sense, yeah, but I don't know how it works.
Well, you can hire me and I can no. Yep. Yes, I mean, you pretty much have something like if you have warning or whatever. No, I'm not going to write this because, but in your logic you have a block where you probably have just an if that checks if you're in a warning state, if something is broken, right? And then you would just call a function from that, and the function would then gather all the information that's wrong, gather all the additional information you need, and parse it into a way that a human can read.
My question was, is this check working with like 3 broken devices?
Okay. I misunderstood. Okay.
I would want to see if it was expanding the output to add more lines for each device that is not working, or in a different state than OK.
Yes. I don't know anymore, actually, because it's quite a while since I've written this.
Okay, so it's just an example for checks that.
Yes. Okay. Yes.
Do you use or do you recommend to use modules for writing plugins, for instance, for Python?
The question was, do I use modules if I write it in Python? And the answer is yes-ish. I have a module which is 5 lines of code, which is just, well, okay, maybe it's 10 lines of code, which is just, it's called SSH command. It's somewhere in here. And I mean, this is just because I do every stuff via SSH, right? So this is just a really simple class that checks a couple things to make sure SSH actually exists on your system and so on and so forth. And then you just send it like the host name and username and command, and then it just runs that and gives you a nice output back. But I have thought about writing more. Especially, I've thought about writing a better SNMP library, like not one that actually implements SNMP myself. I'm not crazy, but the problem is if you have SNMP, you have lots of like numbers that you need to translate back, right? As I said, my example with the Synology check, where you have system state like 1 to 5, the question is, how do I know what's what, right? And the moment it has this dictionary, right, which is used to translate, so it's kind of like a MIP, right, which is used to translate these things back, but it kind of sucks, and there's a lot of work to do. So I thought about writing some more modules that make this easier. Also writing a module that has kind of the blueprint of a check, where you just say, okay, like I give you this number, right? And then I give you warning and a critical thing, and then it implements all the logic and has a callback function to, if it's warning, okay, it has a callback function, and then this callback function would aggregate all the information and give it back the output. So yes, I thought about it. Whether or not I'm going to do it, I don't know. Yes?
Maybe a little bit off topic, but how do you secure the SSH box with your target machine, which you want to monitor?
Oh, yeah. How do I secure the target machine? That's a really good question, because if you have a check that's local, all you can limit the user to that one check, right? But as soon as you gather the data via SSH, there's way more stuff that the user that SSH is in has to be allowed to do, right? For example, my memory check uses proc meminfo, right? So the user would need to be able to access that. So it becomes more difficult to do all of this, but you can still limit users to particular commands, right? And that's the way it's secured. You can, for example, you can use sudo, for example, for individual commands and so on, right?
Why not using more passive checks to make the setup more secure? Clients can also send NSCA.
I don't really understand what you're asking.
Using passive check on the client, so the monitoring server does not need to query.
Oh, yeah.
Clients just send.
Oh, yeah, you mean, okay. So the question was, why not using a push-based over a pull-based approach, basically? That's fine as well. If in your environment that makes sense, then you can do that. In my environment, like most of the stuff I monitor is SNMP anyway, or IPMI, right? So the times where I have VMs where I query VMware SIM, which we all already heard about today. So there are actually only very few cases where I actually have to SSH into a box. It's mostly stuff like this, when it's a physical box and I have to check memory or so on. I can't use SIM, right? But there isn't a particular reason why I use SSH checks other than I like it to be agentless. However, we do actually also have some checks that have an agent installed, which we just push out via Puppet. So that can also work. Okay. Yeah.
How about splitting this service for all the disks?
Yes.
Per disk services, and have one global which covers the rest, for example, with the dependencies?
You can do that as well, if you want to. Mostly, like I started having it in one check because then you only have one monitoring plugin that you need to write, right? And then it just iterates through all the disks. And this way it's less work in the end. You would run into a similar problem if you had a service for every single disk, and that now you have lots and lots and lots and lots and lots of services. Every single service has to be executed by the Icinga node, so all of this is a little bit overhead for your machine. But it's possible. The reason I did it this way is laziness, which is a valid reason, I think. All right. Thank you all for listening.
Thanks for the great talk. Thanks.